Hi everyone! In today's video, I'm going to show you Entity Framework Extensions Library in depth. We will explore a big number of customizable options we have in this library. Entity Framework Extensions Library, as you know, is famous for its fastest bulk operations in the market. It supports various database providers and provides various methods for bulk write operations, such as bulk insert, update, delete, merge, and synchronize. Let's explore what options we have with bulk operations. Entity Framework Extensions Library is famous for its hundreds of available options. These options will save you hours or even days of tedious coding, which is subject to bugs. Let's explore the project we will be using today. It's an IoT device application that has three main tables: devices, which represent IoT devices, components of these devices, and telemetry data from these devices. In our ASP.NET Core application, we have three main entities: device, component, and telemetry. In program.cs, we have configured our SQL Server database, and we run migrations at startup. We will be testing all options in the following options service class. Here I use the Bogus library to create realistic IoT devices, and I specify the randomized receipt for our randomized result to be consistent across our application restarts. So, to get started with Entity Framework Extensions library, you need to install the following NuGet package: the Entity Framework Extensions EF Core. Let's explore how we can perform a bulk insert of IoT devices into our database. Let's generate a few devices, let's say 10 devices. And now in the DB context, Entity Framework Extensions library provides various extensions methods, such as bulk insert async. Both async and sync version of this method is available. Let's use async and provide our list of devices. Let's run our application. Okay, let's explore our database. And as you can see, we have 10 devices inserted. Let's explore what options we have when performing bulk insert. As a second parameter, it accepts an options delegate. In this options delegate, you can specify various configurable options. Let's explore a few most important options. One of the options is called insert if not exists. This option allows to insert only the entities that don't already exist in the database. Let's explore how it works. First, we will insert 10 random IoT devices to our database, and we will try to insert them again with this option enabled. Let's debug and see how it works. Okay, the first bulk insert option is completed, and in our database, we can explore 10 created IoT devices. Let's run the second query. And as you can see, we don't have another 10 devices inserted to the database. By default, Entity Framework Extensions library matches the entities by its primary key. In our case, in the device, it will be the device ID. But you can customize this behavior. We have a column primary key expression, and here you can specify the delegate. You can specify any meaningful property or even a group of properties in your entity. For example, we can match our IoT devices by name or a serial number. In this application, for our device entity, we use a long type in our C# entity, and we use a database identity in our SQL Server database. But we have an option in the EF Core extensions library. Let's get rid of the second bulk insert. And this option allows you to insert keep identity. When you enable this option, you are inserting custom identity values instead of letting the database to create them. Let's generate a few custom IDs, and let's make our example simple and create only 2 devices. Let's specify device ID to 1000 for the first device and 1001 for the second. Let's debug and see how it works. Okay, our bulk insert operation is complete. And as you can see, we have inserted new devices with our custom provided primary keys. This option is particularly useful when you synchronize data from other services or external providers and you want to keep your identity values in sync with that systems. Another useful option in the bulk insert method is automap output direction. By default, this option is set to true. After we insert our devices, when we will explore the list of inserted devices, as you can see, we have assigned primary keys by the database identity. And these identity values for the primary case and any columns that are populated by the database are automatically returned after insertion. When we don't need to use these database generated values, we can specify this automap output direction to false. As you can see, after inserting our devices, we do not longer have our device ID property populated. This improves performance. By the way, there is another DB context bulk insert method called bulk insert optimized. And this method is exactly the bulk insert with automap direction put to false. Let's insert 10 devices with bulk insert and with bulk insert optimized method. We'll set output direction to true. We will create a stopwatch. And we will stop the stopwatch after each method and compare the performance. Let's specify 10,000 records so we can see the difference, and let's debug the application. Okay, our first regular bulk insert method completed in 600 milliseconds and another one in less than 200. So we have more than 2x performance improvement. Let's explore another useful option. Let's comment out all this previously created code and let's create 10 devices. I have prepared a new method that creates IoT devices components. For each device, we will create a list of 3 components. So we can specify components, generate 3 components. We will call DB context bulk insert method. And one of the options we have is called include graph option. This option allows you to automatically insert related entities found in the graph of objects and preserve their relationships. Let's run and see how it goes. Okay, our devices are inserted. And when we open the components tab, as you can see, we have generated 30 components, 3 for each of 10 devices. This is a very useful option. Typically, achieved with one line of code in EF Core extensions. And imagine how much code you will write when using SQL bulk copy. Behind the scenes, I have cleaned up our previous code, and you can explore other previous examples in a separate private methods. Let's explore another useful option when performing a bulk insert. This option is called auto truncate. If you set this value to true and you have a maximum length specified in your entity framework mapping, so your string values will automatically be truncated to match the maximum database length before inserting. So if you specify some long text, for example, for our hardware version that has a limit of 50 symbols, it will be truncated. Let's run our application and see how it looks like in the database. Let's explore our inserted devices. And here you can see that our text was truncated to fit the limit of 50 characters. Let's explore more options we have for Entity Framework extensions in the official documentation. You can find all the available options in the documentation, and you can explore various options for columns, for bulk options, for batch operations. We have a pretty important batch options available. We have a batch size, a batch timeout, and a batch delay interval. Batch size option allows you to specify how many rows are included in each batch. One batch equals to one database round trip. And for various database provider, we have different options. The batch options in the EF Core extensions library come with great defaults, so they are a good starting point. But in some cases, you need to tune these values to bigger or a smaller value depending on your use case, number of columns, tables, database provider, and your database provider server performance. So you can customize how many entities are sent in each request from your application to the database. You can specify the maximum time to wait for each batch to be inserted or updated if you use another bulk options, and the delay interval in milliseconds between the batches are sended. We have briefly explored how we can customize the primary key during bulk inserts. However, when you have a complex primary key which consists of a few fields, you can specify this by providing an anonymous object. In this anonymous object, you can specify the few fields for your primary key expression. Another useful option is called column primary key names. This option accepts a list of strings of primary key names. You can specify this by providing a list and specifying your column names as string properties. This is particularly useful when your primary key names are identified only in the runtime. The third and most complex option we have for configuring primary keys is called insert primary key and formula. In this property, you can specify a string SQL custom code, but this is not a safe option, as you can't validate it during the compile time. Entity Framework Extensions library is a paid library and you need a commercial license for production usage. However, you can download a free trial and you can extend this trial each month by downloading the latest version. This is useful for testing if this library meets your project needs. For commercial usage, the time saved in development and the improved application performance typically pay for the license within the first months of use. As we have explored various options, that these options, in addition to bulk write operations, can save you hours and days of development. Thank you for your attention.